Lesson 10 is also a short lesson, just like 9 was, and it's on the Pythagorean theorem. And you've used this before. You've used this since you were probably in elementary school. And if you remember, the Pythagorean theorem is a squared plus b squared equals c squared. You will continue to use this theorem all the way up through calculus. So it's kind of a nice one to have in your math tool belt. That's kind of a dumb way to say it, but math geniuses use that phrase, I guess. The way that works is we take two sides and square them each and then add them. So we take one side plus another side, and that equals the hypotenuse. Always the hypotenuse. Always the line segment across from the right angle there, the 90-degree angle. So we get a squared plus 16 equals 49. Subtract 16 from both sides. A squared equals, let's see, 33. Then we take the square root of both sides, and a equals the square root of 33. You can't reduce that at all, so we're done. So that means that in this particular triangle, if this is 4 and this is 7, this length here is the square root of 33, which is right somewhere between 5 and 6, closer to 6 probably, because 6 times 6 is 36, 5 times 5 is 25, and 33 is closer to 36. So anyway, if you look at example 10.2, use the Pythagorean to find the distance between 2 points. Okay, so they're going to make it a little bit tougher on you. So let's use this picture here. It gives us 2 points. It gives us 4, 2, and it also gives us the point -3, 4. So let's graph 4, 2. 1, 2, 3, 4, 1, 2. Probably should do it with another color other than white, since I'm trying to do it on a white piece. There's 4, 2. -3, 4. -3, 1, 2, 3, 4. It's right there. Okay, so there's my 2 points, and they want to know how far it is between here and here. Alright, so what we're going to do here is we're going to make a triangle here. We're going to make this go down and then this go over. And this is 2, and the distance between, let's show it in blue here, here and here is what? 1, 2, 3, 4, 5, 6, 7. This is going to be 7. And we're looking at the distance between here, here, and here. So we're looking for the hypotenuse. So we're going to use a squared plus b squared equals c squared. And again, a and b are both the short ends, or short sides. The hypotenuse is always the c, so we're going to take 2 squared plus 7 squared equals c squared. So 4 plus 49 equals c squared. 53 equals c squared. Square root. 53 cannot be broken down, so the hypotenuse, c, is the square root of 53, which is somewhere, let's see, 7 times 7 is 49, so it's a little bigger than 7. So it's just a little bit bigger than 7. And that's pretty much all you need to do there to figure out how far it is between those 2 points. So let's go ahead and throw the problem set in this particular video because we're only 4 minutes into it. So problem set 10, A and B, we're using the Pythagorean theorem. We just did 2 exact examples like that. Number 1, 20% of the people at the fair. Okay, so again, make sure that you use the right ideas when you're putting those two together. So 20% of the people were in a festive mood. So that doesn't mean that everybody was in a festive mood. It just means that 20% were. 1,400 were not in a festive mood. So if 20% were, that means 80% were not. So 80% of the total were not in a festive mood. and that is a total of 1,400 that were not festive, and that's 80% of the total. So if I take 80% or 0.80 times total, gives me 1,400, divide by 0.8, divide by 0.8, those go away, and that gives me the total number that were at the fair, like they were asking for. So anyway, same one. Number 3 is very similar to that. Number 6 is very similar. Just don't worry about the names. Give them the names of Sam and Marty or something instead of number 6. Atreus could use 4,200 argives. I mean, what the heck is an argive? And why would you name your kid Atreus? So anyway, ignore the weird names and just do the best you can with those. 13 gives you a chance to use Pythagorean to find P, and that is not the hypotenuse. 14 is another one, just like the practice problem was that we did for practice B and the example 10.2, and everything else looks again like review. So that is the lecture and the problem set for lesson 10.